We're going to do something here that's completely equivalent to what we did in the last clip with the function h of ty, but we're going to do it in slightly different notation. So f of ty is t squared square root of y plus 1 over y. Okay? So df dt is what? Treating y as a function of t, df dt is 2t square root of y plus t squared y prime times 1 over 2 square root of y plus y prime times negative 1 over y squared. So that df, well, let's write this out one more step. 2t square root of y plus t squared dy dt times 1 over 2 square root of y plus dy dt times negative 1 over y squared. And I could have put my negative here and didn't think of it. Okay. All I've done in this step is replace y prime by dy dt. So if df dt equals this, then what does df equal? Well, again, theoretically, it's not a multiplication by dt, but for the purposes of this course, we can kind of treat it that way. So we have 2t square root of y dt plus t squared over 2 square root of y, put that in parentheses, times dy minus 1 over y squared times dy. Now, we write the equation df equals 0. Okay, df equals 0 is just this equals 0. That equation is just 2t square root of y dt plus, and let's factor all this out of the dy, and we have t squared or over 2 square root of y minus 1 over y squared dy equals 0. Okay, that's our equation, df equals 0. Now, again, it might not be completely obvious what the advantage of this is, but I'll write out a statement here that df equals 0 if and only if f equals some constant. So again, this equation has a solution which consists of this expression equal to some constant, and that could be any constant, arbitrary constant. Once more, the form of this is m of ty plus m of ty dt plus n of ty dy, and I sometimes reverse the roles of m and n. I don't always get them the same as the book, and I think I'm in a different order from the book here, maybe in a different order from the last clip, but that really doesn't matter as long as you're careful about what means what. So m of ty dt, m of ty is whatever is in front of the dt. So m equals what? M equals 2t square root of y. N equals t squared over 2 square root of y minus 1 over y squared. We can apply the same criterion we did before. Does dm dy equal dn dt? And we find, well, dm dy is 2t over 2 square root of y, which is just t over the square root of y. dn dt is 2t over 2 square root of y, which is again square root of t over y. So this equals the square root of t over y. This equals the square root of t over y. And we shouldn't be surprised from what we've seen before.